Last but not least, we have CJ Jenkins, a senior data scientist at Klarna, and she will talk about encoding tricky data. High cardinality and categorical variables and text variables make for complicated feature encoding. So CJ, please take away from me.
Okay, everyone can see my screen. Can someone give me a thumbs up?
Yes.
Great, perfect. Okay, so I'm going to talk about encoding tricky data, and then the rest of the title explains exactly what I'll be doing. But I want to start by saying I'm a senior data scientist at Klarna. So we're the leading global retail bank, payments and shopping service. And we also have a lot more. We've got 90 million global shoppers, 2 million transactions per day. Lots of people are downloading our app, thousands of retailers. There's a lot going on, and tons of employees. So within that, I work within the Klarna app, which is a portal essentially to use Klarna payments anywhere on the web. So it's nice that this is in Stockholm because I can explain, like, you can use our pay later invoice product or our slice it product. And we do that by one-time cards, which you then can use at Walmart, at Lego, at Amazon, at Nike. So basically anywhere you want from within our Klarna app, which is great. And it opens all sorts of possibilities, but it also opens a fair amount of risk. And so at the point of transaction where the user is using the Klarna product to make a transaction is where my machine learning algorithms live, where we potentially block transactions that look like they're going to be too risky. And while I'm doing this, I have a ton of categorical variables that I use. And I should mention that I'm primarily using gradient boosted algorithms, like we've gotten deep into cat boost, but also like GBM. And the problem with categorical variables is that often the most popular way to currently encode categorical variables so that they're better machine readable is to do one hot encoding. And so for those of you who aren't familiar with it, one hot encoding essentially takes my categorical variable, here brand, and instead of having categories, it spreads it out so that each individual brand becomes its own feature. And so then you can label the transactions as either having that brand or not having that brand, which works really well if you have categorical variables that don't have that many categories, right? So here we only have 3 categories. But if you start expanding it out to all of the categories that we see on the entire internet, you quickly get into so many thousands of brands that your feature space has just exploded into 40,000 features. And it generates a really sparse matrix, which some machine learning algorithms, particularly gradient boosted trees like cat boost, don't deal as well with. And so to combat this, we had to do a number of things. But the reason we had to combat this is that I mostly am dealing with categorical variables of really high cardinality within my model. So I'm trying to avoid anything that's done by the credit team already. And so we focus on the things that are available at the point of transaction, which is a lot of merchant information. So by merchants, I mean brands or brand category, like the brand category code that's provided by Visa, and also the merchant acquirer. And you can see that for merchant brands, we have well over 100,000. For merchant categories, you have well over 2,000. For acquirers, you have 5,000. This is really quickly going to result in an insanely large feature space, which why most of my colleagues, when they're building machine learning algorithms, would just take something that high cardinality and just throw that feature out. Be like, it's not going to be worthwhile trying to figure out how to encode it. We'll just get rid of it. But that's where all of my information is. Most of our ability to predict whether or not a transaction is risky is based off of these 3 categories interacting with each other. So not ideal, but what we ultimately started to do is the first thing is try to get rid of a lot of try to reduce the cardinality to start with. So my PR department would want me to tell you that this is made up data, but it's similar to what we're seeing, but not exactly the same. So on the y-axis, you have the number of transactions, and then the x-axis you have our various merchants. And what you can see is that you have this long tail, right? So you have a couple of merchants that we see all the time, and then we see a lot of merchants that we very rarely see. Those aren't actually going to contribute much to our analysis of risk, because if we only see it once or twice, then you could either default all the time or default nothing. It's not going to contribute to how we're able to assess new transactions. And so for all of merchants that were below 3% in the market, I just set those to one category. And so I just call those rare, which then reduces a lot of that cardinality, although not nearly as much as one would like. We then have text variables, like Amazon. As a person, I can look at this and say like, okay, all 5 of those are clearly Amazon. But if I were to just encode this as a category, each of those would be encoded as its own category, which again, increases the cardinality that I'm trying to reduce. And so I use TF-IDF to collect an informative library of like the most important text words that we see. And then I just mapped those to the data space. And so it reduces the top 25 most common words or most common merchants and collapses those into one category. So instead of saying 5 Amazons and like 6 Walmarts, I'm seeing 1 Amazon and 1 Walmart, and it becomes a lot more predictive and reduces my cardinality space. And then finally, what I did is rather than doing one hot encoder, I tried a couple of different encoders, but we ended on the one that was best, is target encoding. It's not as popular, but I think it's pretty great. It specifically was written for high cardinality categorical variables. And what it does is for each of the brands, you can see on the left, you take their average target. So here it's paid us back or didn't pay us back. Again, this is entirely made up data, but it's pay us back or not pay us back. And then we use that average to just map that onto each of the individual transactions. Now, this does result in a little bit of data leakage because we're using our target to map our training data, but it's not significant enough that it changes the model in live production, and that like our live production predictions are about what we would expect when it's static. So that little caveat of like, it does cause some data leakage didn't actually impact my model. Cool. And with that, I want to thank you for your time, and all the other speakers were also fantastic. So I want to take a moment to thank them for their talks, and I will take any questions.
Thank you, CJ. Great talk. And I absolutely agree with you. All the talks are super interesting. So we are going to the Q&A. And the first question, have you tried different grouping of merchants based on, wait a minute, let me read one second. Have you tried different grouping of merchants based on, for example, different metadata?
So we do group our merchants in a number of ways. And one of the ones I mentioned was category. And so Visa gives us what's called a merchant category code, which groups merchants based on what they're selling and that they set at the merchant at the time when they first integrate with Visa. So we do that. And then we also group those categories into like a slightly less granular, because there's about 2,000 merchant category codes. And we have about 100 categories that we derive from that as well. So yeah, we include that.
Okay, so it's problem inside the problem.
Mm-hmm.
Another question, do you monitor the data drift for the target encoding in production?
Yes. So I probably, my risk people are going to get real angry if I talk too much about this, but yes, we actively do monitor our models, both the variables and how those drift over time, and then the model itself and how its performance potentially changes of the population over time.
Thank you. And I think follow-up question, how often do you have to retrain your model? It's probably, so the data must change quite much frequently.
You'd be surprised. So it depends actually on how long the market has been live. So for example, when we launched in Australia, we had a model up and running at the time of launch using transfer learning from other markets. And then the newer markets tend to, like the behavior tends to change pretty quickly. So you see a lot of covariate drift. And so in Australia, we had to retrain the model like once a month at first, and then we moved it to like once a quarter. And now the population is pretty stable. So I'm guessing about once every 6 months. And we've seen that in the US, in Australia, and in other places that we will be launching soon.
Interesting, thank you. Actually, I have a follow-up question on your answer. But if you have such events like COVID, for instance, do you then trigger your retraining manually? Because I assume then the behavior actually changes a lot.
Yeah. The behavior for most of, So I'm just trying to figure out what I can't say. So for COVID, we definitely tightened down the policy, and that changed the underlying population. And so we don't retrain it that much, because since we tightened down the risk policy, we're just seeing a lot, like slightly less risky users. And so the model is actually functioning just fine. But yeah, that's a good question.
Interesting, thank you. So we have 1 more minute and I have 2 more questions.
Great.
Are you manually grouping the text variables, Amazon, Amazon.com, and maybe other identifiers connected to Amazon, etc.? Or do you use some advanced techniques?
It's a combination of the two. So I did TF-IDF to generate like a vocabulary of like the most impactful merchant names. And then from there, I curated that dictionary to make sure that things were grouped together. So it was a combination of like technical and not technical. It was actually, I thought about including in that slide that I kind of have a plea for help, and I've spoken to the sklearn, like some of the sklearn contributors.
How about now? Yes, perfect.
What was
Okay. that? I don't know, but please continue.
Is that like, it's so frustrating that there are all these great NLP encoders and like NLP software out there, and like very few of them are built within a pipeline so that you can easily apply it on just like one column in a data frame. But for our purposes at the moment, just doing this combination of TF-IDF and then like manually reviewing and adjusting them is working out pretty well.
Thank you. And the last question. What tool do you use for data modeling?
For building the algorithms?
I assume yes.
Or
for data engineering?
Yeah. So everything I do is in Python. And so, I mean, I train the models using SageMaker because they're pretty hefty. And we also have a number of ML servers. But like, yeah, everything is just written in just training code in Python.
And what do you use for monitoring?
For monitoring, we have all of my machine learning algorithms are hosted on as Docker containers. And so we have within the container embedded monitoring for the variables. And so that gets constantly pushing information to Datadog. And then we have triggers set up in Datadog. And then for the model, actually looking at the model, I just have everything put into one of our SQL databases. And then that's linked to a dashboard that also has an alert, so that if the population changes too much, I can go take a look at it.
Thank you so much, CJ, and I hope you are going to stay for Mingle and more questions will come.